Well, I want to thank the program committee for inviting me. It is an honor, and I am truly grateful to be able to talk to you from across the ocean and clear across the continent of America from San Francisco. It is always, for me, very humbling and wonderful experience to realize that in foreign countries where English is not the native tongue, they nevertheless understand me. And this is wonderful because wherever I go to speak, this is true. English has become a universal language. I'm very fortunate for that. I don't know what history really led to this despicable situation. The language is perfectly good for me. I should like, before I launch into my talk, to describe a little bit about myself personally so that we have some idea of who you are listening to. Perhaps some of you are wondering what part of the country I came from and where my ancestors came from. My parents came from Japan in the early 20th century, where they were farmers, and I grew up in the Central Valley of California, and there I experienced many of the difficulties that persons of ethnic minorities experience in California and elsewhere. At the time, it was not possible for my parents to own property, and neither was it possible for them to become naturalized citizens. And that was even before World War II. So there was a fairly substantial historic basis for ethnic prejudice operating, and that is true for all Asians at that time. Not just Japanese, but Chinese and others. I went to high school in California, and there I was become familiar with the process of chicken farming, because in our rural areas, the federal government had introduced a program for training in agriculture for the high school students. I had 600 laying hens, and I was the proud owner with ambitions to own thousands of such chickens, known to be bred for their egg-laying capacity. That was my ambition at the time in high school. Unfortunately, World War II ended all that because all of the Japanese persons living in California, Washington, and Oregon were required to be in effectively what were prisons known as relocation centers throughout the western United States. Fortunately, we were not mistreated. We were fed healthy meals, had housing in the barracks, and often had employment in the camps maintaining them. I also enjoyed the company of my peers. I became quite adept at playing baseball in these camps. So it was not a total miserable experience. In fact, being developed in a farming area, it was in some sense a relief not to have to go to work out in the fields every day, and I could instead play baseball. I should like, for the rest of my talk, to read my manuscript, because I tend to wander when I talk extemporaneously, and sometimes that just results in extra time delays and irrelevancies. So if you would excuse me, I will sit down and read you this manuscript. Okay? I've already said a couple of the first pages to you already. How I came to be interested in biofeedback may be of interest, and if you excuse me also, because I had a recent knee operation, I should prefer to sit rather than stand all this time, okay? Unfortunately, that makes me invisible to some of you in the rear seats, but maybe I can make up for it by being clearly audible. How I came to be interested in the field of biofeedback may be of interest because I approached it not from the point of view of any potential therapeutic or other health providing uses or other applications, because none were known at the time. I was interested in the relationship between brainwave patterns and the events of consciousness. I had been engaged in a project at the University of Chicago where I started my academic career in 1953. I was studying dreams and sleep in the laboratory of Nathaniel Kleitman and his student William Dement, who is now a professor at Stanford University. The study of dreaming sleep was an excellent place to start for people like myself who were interested in the process of introspection and retrospective reporting of events known only to the person. Though I went on to continue the project on sleep and dreams and verified the work originally done by Dement and Kleitman, I became interested in other observations about the waking person. But before I go on to that, if I may have the first slide, I should like to discuss a concept that is, I believe, important in understanding the role of hypothetical constructs in science, where the constructs often refer to private events, such as dreams. We know that dreams are real from our own private experience, but when it comes to thinking about the dreams of others, we often run into various controversies concerning the scientific validity or legitimacy of concepts about the private experience of others. It is hypothetical. The thing that helped understand the process of science in this field was the fact that rapid eye movements and slowed up, changed stage 1 REM EEG had become quite useful indicators of people dreaming while they were asleep, as indicated by the fact that when they were awakened, when they showed specific signs of rapid eye movements and stage 1 EEG, they would typically report a dream experience much more often than when they did not have such rapid eye movements, and the verbal report would be what caused people to say, hey, we now have an objective indicator of dream experience. If you notice, what's happening here is that we have a process of convergence of two classes of observables: the verbal report, the introspective report, and the physiologic indicators, in this case, rapid eye movements and EEG changes. Now, they happen to correlate with the reports of dreams, so this tends to give more legitimacy of dreaming as a scientific concept because there are more convergent indicators. It's that way with many of the other kinds of psychological constructs that we create, because we use them in concert with convergent indicators, or potentially convergent indicators. And so this was kind of a useful concept to ward off the very strict behaviorism that tended to become very popular, in which any appeal to private experiences were almost illegal in our field of psychology. I think that what we need to do is to, and have become more grown up about that matter, and recognize the status of these hypothetical constructs like dreaming. To talk now about what it was about the waking EEG, here I have a sample of the EEG alpha rhythm, about perhaps 20 seconds worth, or perhaps maybe a little bit more. Notice how there's an occasional, rather regular rhythm. It happens to be about 10 to 12 cycles per second. That is known as the alpha rhythm, and it becomes usually found in most adults when their eyes are closed and they're sitting quietly. They come and go, but their pattern of appearance and disappearance is not precisely timed. It's very often difficult to predict when next there will be. This one happens to be highly regular. What I began to wonder about that event was, I wonder if there's something subjectively different in the person's mind at the time he or she is having these alpha rhythms, as opposed to the moments when he or she is not having such a rhythm. And being at the University of Chicago at the time, which was a hotbed of behaviorism and discrimination training with operant conditioning, I learned the concept that discrimination training is a very valuable thing in understanding behavior, in which correct responses to choices in the environment result in reinforcement. In the case of the dreaming, I have diagrammed in the next slide a series of vertical lines, and they are to represent the irregular appearance of the alpha rhythm in a single individual, several, almost a minute's worth, I guess. And every place I have a question mark, that was the prompt that I did with a single ding of a bell, like ding, which was the prompt for the person to guess whether he was in state A or state B. My rule was, if he said A when he was at alpha, with these wavy lines, I'd say correct. If he said B, I said wrong. I gave him only two states of mind, A or B. And so I asked him to make a guess, and I would correct him, tell him whether his response was correct or incorrect with every trial immediately. Well, initially, in the first session, the subject achieved only about 50% accuracy, and it happens that he would have done almost as well by simply flipping a coin. But on the second day, he got something like 60%, which was not yet much to write home about. But on the third day, he got 80%, and now things were getting interesting. 80% accuracy, and on the fourth day, I guess it was even 85%. I've forgotten the exact figures, it doesn't matter. On the fourth day, after one mistake, this subject, a college junior, major in chemistry at the University of Chicago, got every single trial correct. He kept being so accurate that I went beyond the usual 60 trials that I gave him and ran up as many as 400 trials on this person. He never missed a one until somewhere around the 400th trial, he deliberately gave me a wrong response because he thought maybe I was pulling his leg, saying correct to everything he said. Well, when I said incorrect, that really shook him up and convinced him that, hey, he was making right guesses. And this is the interesting thing about this process of discriminating an internal event that is presumed to be associated with some physiologic activity. Turning now to the question of the subjective experience that might have been associated that made it possible for him to say correctly these things, it was rather disappointing. I asked him, how do you know the difference? He was really quite inarticulate. He said, gee, this very first subject, junior chemistry major, said, gee, it sometimes feels like I should say A, other times I should say B, which was not very articulate insofar as explaining the experience. But he certainly labeled them correctly. And this has been the problem for some that arose in, with many of these trials. I was very gratified to see that most people could learn to do this discrimination, although not to the accuracy of my very first subject, who I still say was sent by God to encourage me on to do these experiments. Most subjects settle down at around about 85 or 90% accuracy. Some we have to run even more trials to show that they have achieved a significant proportion of correct trials. Now, I think that what was interesting, though, is that this procedure has certain drawbacks to it. Because, first off, he's being reinforced only occasionally, when sometimes we could be actually sampling all the rest. Sometime in the course of this, by the way, we discovered an interesting fact, that not only could our best subjects, the most adept ones, get almost all correct, if not all, but they could also, on their own, without the bell ding happening, report spontaneously whether they were having an alpha rhythm or not. They could sit there and say A, B, A, B, A, B, and so on, quite accurately. Moreover, these people, I found, the most adept ones, could, upon command, produce the states that I asked them to. Let's say you produce the state you've been calling A, and along would come a string of alpha waves that would fill an entire page of EEG records. That would be a 20-second stretch in by this, our recording system. Well, that was very intriguing, that, hey, we are now also involved in training people with the control of their own states, even though we weren't intending to do so. Thinking that perhaps we could get to this question of control without giving any discrimination training, what we did was to arrange for one of my technicians, who happened to be adept in electronics, to arrange to have a tone sound whenever the alpha rhythm appeared. That took a little bit of electronic filtering and so on, but without bothering you with the details of that, this was a tone that would go on whenever alpha was there and would disappear when alpha stopped. With that system, we could ask the person, can you increase the proportion of time that alpha is present? Or conversely, later we found the same thing, can you decrease the proportion of time that the alpha is present? The subject indeed could do so. And this was a very remarkable, but it points to the fact that when you provide a continuous feedback signal like this, as opposed to a single trial, single ding of a bell, you are actually giving the subject much more information per unit time about his state of mind, because you're also showing the very momentary fluctuations. The instant one happens that the alpha appears, he can begin trying to find what subjective state was associated with that start. Well, the experiment was quite remarkable in that people could learn this task of either increasing or decreasing their alpha activity quite well. So I now believe, thinking about these two experiments of discrimination training and this kind of biofeedback system, that the biofeedback system was superior in the sense that it gave continuously feedback, the information upon which the person could make his judgment, whereas in the discrimination training situation, it was only one single moment when a bell sounded and he had to make a guess. It's remarkable that they were even able to do that. Maybe that first person sent by God was useful after all. In any case, what I was going to say is that with a continuous feedback system, you do have much more information being provided per unit time about the internal, and much better possibilities of finding a subjective correlate of that very same thing. Well, let's have a look at the next slide. This is taken from Barry Sturman, when he asks, is brain behavior behavior? If so, it can be conditioned just like any other behavior. Well, Barry Sturman heard me present about this alpha work at one time at a conference in New York, and he thought it was quite intriguing, and he ought to try it out with his cats, which he was doing some experiments with for the federal government. This method of continuous feedback, we originally just simply called it feedback, but at a conference, I think about in 1958 perhaps, we had a meeting of researchers who had become interested in this process, and we decided to call it biofeedback. And then later, if the biofeedback was done with neurophysiologic variables like EEG, it was called neurofeedback. So those are the designations now standing for that area. Nowadays, biofeedback is everything other than neurofeedback. Whether that's heart rate variability or muscle tension or blood pressure or whatever. Okay. In this question was raised by Sturman, and he went and actually tried it out on his cats and found, lo and behold, cats can be conditioned to produce this particular rhythm, which he named the Sensorimotor Rhythm, which is around about 14 hertz, spindle-shaped activity that cats have. And epileptic cats have very little of that kind of seizure, so that kind of EEG pattern. So when he trained his cats to produce that SMR rhythm, the sensorimotor rhythm, the cats showed less frequent epileptic seizures. So that became a very important clinical application of neurofeedback. It was one of the first. And I think that it is important for us to realize that we are able to train animals and humans to produce different things, and even though they may not be able to articulate very clearly in words just how they are doing these tasks, they can learn to control the physiologic variable. But that points to an interesting problem, because when you think about it, biofeedback is nothing more than behavioral training in which reinforcement is given for a response that occurs. And so we're clearly reinforcing something, a complex internal behavior, an internal mental event, if you want to call it that, that is effective in producing the specific change in physiology. In this case, the sensorimotor rhythm, or in my case, the alpha rhythm. So I believe that it is a challenge for us, especially as psychologists, but certainly for all of us really, just exactly what are we training when we train with biofeedback? What is that internal behavior? Well, we at present time have a very poor method of specifying just exactly what those internal behaviors is. In a certain sense, it's a kind of an embarrassment to us because we're using technology of behavioral training, which is successful, but it's applied now to, let's say, very successfully to the treatment of various kinds of disorders and so on. But at the same time, we don't know much about specifically the internal behaviors. To a clinician who is training people, perhaps this question is not of particular importance, because after all, for disorder A, you provide feedback modality B, provided it's been shown to be effective in treating a disorder. And so why bother yourself to think about what it is, the mental processes that are being done? But I think it's an interesting problem, and I think that there are ways that could help actually begin to unravel that, and I will turn to that fairly soon. Is there any questions so far about what I've said so far?
Nur eine kurze Frage. Wo ist der Alpha-Rhythmus gemessen worden? Ist der okzipital gemessen worden an einer oder mehreren Stellen?
Where did you measure the alpha rhythm? At which
Okay, good question. I measured the alpha rhythm from left ear to left occiput. That's where alpha rhythms can be found rather prominently, and actually it would work also at left central and even left frontal with some people, but the left occiput is where the alpha rhythm is most prominent, and so that's where I chose to work it with it. The subject sat in a darkened room, eyes closed, and I gave them the instruction to make guesses, whether it's A or B every time I dinged the bell. And I said correct or incorrect. Yes?
This is closely related to closing eyes and open eyes.
Yes, it is. Yes, it is. That's the man points out that if any subject with any alpha at all, when he closes his eyes, will show a dominance of alpha. But in our experiments, the eyes were closed in a darkened room. And so it brought out the normally higher level of alpha that one sees with eyes closed, but it does not continue to grow as the eyes are closed. In order to get the alpha activity to be still higher, one can use the conditioning procedures that we did use to increase the percentage of the portion of time alpha is present, or conversely to decrease it, again with eyes closed throughout. Obviously, if you wanted to really cheat, you just have to open your eyes and you could have no alpha at all. But we had ways to monitor whether the eyes were open or closed. If the eyes remain open for any time, you could count on they're seeing blinks. And so by simply placing electrodes supra and infra orbitally, you can detect whether the person is sitting there with his eyes open or closed. So it was, of course, quite important that the person remain with his eyes closed in these experiments. Are there any questions? Yes.
I always find at O2 a bigger alpha, not in O1.
Oh, okay. He's seeing that he sees more at O2 than at O1. That is to say, he sees more at the right occiput than he does at the left occiput. I don't know about that because I simply haven't explored that issue. Is it a really very strong difference?
I mean, you can see in all the databases, you know, the normative databases.
Yeah, well, okay. But I would think that wherever you start, if you stayed on the same side, you could still show the same increase or decrease. Yeah, okay. Other questions? I'm glad for these questions because I have glossed over certain important details of the description of these experiments. So, all right, well, we'll go on from there. Yes. What really I want to turn to is this question: what is it? What kind of mental activity anyway is it that we're training? Is it completely random with respect to different subjects? I find that hard to believe, because after all, our neurophysiology was designed by evolution for certain functions, and certainly including certain functions such as visual imagery, or feeling hungry, or solving problems, or tensing muscles. These things you would expect somehow in the EEG world to somehow come out with some degree of agreement among different subjects. Well, okay, it can be said that when the subjects learn to produce increases in alpha, there is a greater proportion of subjects who will use words like, it's very relaxed, or you can it's good to just let it happen rather than to try to make it happen. Don't get too fixated on anything. For suppressing alpha, you will often hear, imagine visual scenes, and especially close-up ones. Those are often quite effective, and a lot of people have discovered that long before I did, that alpha can be suppressed by just voluntarily imagining visual scenes. So those do come out, but still in all, it doesn't seem to, nowhere is there the degree of unanimity that you see in relation to the percent of people who can actually succeed in discriminating the presence. So the question that I wonder is the following: might there be some method where we can use principal components analysis? It's a statistical method to answer this question. After all, there must be only a few dimensions along which people are making these judgments. Let's find out what they are. Let me just illustrate for you what I believe. I must confess, rather naive mathematically, but as I would understand the principal components analysis, which is a kind of a cousin of factor analysis, which I learned in my earlier graduate school days. Let me illustrate it with the following example. Suppose I gave you, with your eyes bandaged and a nose clip on your nose, some 30 different tastes of food substances ground up in a Waring blender, and the same temperature and texture, etc., and asked you to rate the subjective similarity of each one of those food items with every other one. Suppose you had 30, that would give you 30 by 29 by 2 number of individual ratings of similarity. The matrix that would emerge from such judgments can, using principal components analysis, be used to determine how many different major dimensions along which different dimensions are the subjects using to make these judgments, or is a subject using to make these judgments. I think it would be fair to predict, knowing from the domain of taste, that there are 4 specific sensory systems for sweet, sour, bitter, and salty, and now some other people are arguing for another factor called umami. But without getting into that one, there is a certain limited number of primary dimensions along which we would make taste judgments, and I would think you would come out with 4, possibly 5 principal components to account for these. I may be totally wrong about that because of my naivete about principal components analysis, but I want you here to grasp the concept rather than the specifics of the mathematics. If what I say is true, it would be interesting to train people on many different EEG and other physiologic variables to control them, so that they will have a clear sensory appreciation of the difference, even though they could not easily describe those differences. Suppose it's left alpha versus right alpha versus beta versus theta versus heart rate variability versus EMG, etc., etc. Suppose you had 30 of those and trained one person to control those. You might have to have some money to help stay with that job, but I'm talking conceptually here. My guess would be that after he did that and you got this matrix, that you would find that there would be a limited number of principal components which the subject is using to compare the qualities of the different brainwave characteristics or physiologic characteristics. If that is true, I would think that it might be helpful to review with the subject, showing him the principal components, and to discuss with him what kinds of labels might be appropriate for it. I would think now we might be getting a little bit more, because now you have drawn from a wider universe of comparisons for that person to go along with. And especially would it be valuable, I think, to get a half a dozen different subjects thus trained to talk about their experience and to map their principal components. I would predict that they would come out first off with rather similar principal components, because we're all human beings and we evolve these various physiologic characteristics in common with the survival of the fittest. So my guess is that when we get several people talking about it, they would begin to understand a little bit more that there are, yes, differences, and there are certain kinds of words that might be better suited for some of these differences. I draw this example partly because of an experience I had very early in the alpha feedback training business. A couple of subjects whom I had trained were standing in the hallway waiting for their turn to come up for still more training in my lab. And they had become friends by this time and had attended a party the night before. And I heard one say to the other, you know, when Jim started talking about his experience, it sort of made me feel like I had a lot of alpha. And the other guy said, yeah, that's right, What there was here was a communication about an experience drawing similarities between two people, even though they didn't have names for it yet, except what the experimenter said, that's alpha, or A. A is the word we usually use, but we sometimes actually told our subjects, okay, what we were dealing with was alpha and non-alpha, etc. What this suggests is that there is, in fact, a common dimensional capacity of human beings that can be used to characterize the subjective qualities of the different physiologic activities. And that if this is so, perhaps we can get, through the use of additional people to talk to each other about this, and try to get up some kind of words that would help. I think that once that happens, for one thing, I think it would become fairly helpful for new subjects, because they come from the same culture, that if you get into state A, or let's call it dimension 1, you're more likely to have this, that, and the other. And the other person may begin to say, hey, that's right. What I'm saying is you can begin to establish a common vocabulary among people who have never had direct experience except for this kind of training. Now, that's speculation, and only an effort to find out would answer the question. There are several other speculations that I might as well come out with too that I think we might play with at this present time. I think that it might be helpful to convene little small conferences with maybe a dozen people who have been well trained on these sorts of things to talk about the experience and knowing their own principal components. Another thing that I think is that we can perhaps use some trained introspective people who know a lot about their own states of mind, much more than you and I typically, most of us have. And I refer to those who are long-standing meditators from the Eastern traditions, especially those meditation practices focused on attending, keeping alert to whatever's happening in the mind, and noting them and learning about them and identifying them. It may be possible to bring some of those adept persons at meditation, to bring them to the lab, and not only record them as is typically been done in the past, which is by itself useful, by the way. For example, Richie Davidson has shown that when some of the Tibetan meditators get into a state that they call ecstasy, there are very specific magnetic resonance image pictures that can emerge from that state. That's an unusual one, perhaps, but why not pursue that general direction? But more important would be to hook these same meditators up to our EEG and ask them to do our own biofeedback tasks, and ask them to do them and to report to us what they think that's like. I tried a little of that a little ago, and I said, well, what's it like? And what my meditators often said, that's the first stage of meditation that you're giving me. Okay, so at least there's a hint there. I'm running out of time, and let me just simply say the future of research in relating subjective dimensions to what we train in biofeedback, I think will be quite exciting, because there are many other things that not necessarily related to the treatment of disorders, but simply to maintain states of mind of being content with life, being not just freed of various pathologies, but actually being happy. Or let's say also in the area of thinking and problem solving. There are moments when we are more creative than other moments. If we monitor ourselves through 24 hours through modern recording gear, perhaps we can find that there are moments when our EEGs, for example, or MRIs, if we can get one that often enough, to predict when we will be more efficient in thinking. That would be a great device for us, all of us, to learn how to get ourselves in a state of mind such that we are more effective thinkers in the problem-solving mode. The same would go in the creative mode. If you want to create songs or works of art, perhaps there are certain states of brain and mind that can be detected as favoring those, and we may learn how to produce them. The speculation is rampant here, and it's probably time to stop, because we can't live just on speculations, but at least we can think about some of these as potential fields of activity. So thank you very much.
I didn't want to stop you so soon, but I think it would be really interesting to talk with you and to have questions to you. So I hope you can answer some questions. We started with that in the meantime, but ich möchte gerne fragen, ob Sie weitere Fragen haben. Ich denke, die Möglichkeit, Professor Kamiya Fragen zu stellen, gibt es nicht allzu häufig. Ja, bitte.
I have been wondering lately about the alpha state. I mean, whether it more silence is pain everybody has from his history. What state would help people to work through the different experiences? What is your opinion to this? Because I mean, this meditation, relaxation, this more Eastern concept, and then there is more the systemic approach where you really go into a certain feeling again, and so it gets solved and worked through. So I would really be interested what you think about this different approaches.
Different approaches to
life. I mean, it's always to more free and more happy and more creative.
Well, as far as alpha itself is concerned, I do know that a few persons have been helped to overcome anxieties that they had. They're not clinical problems, but enough to bother them some in the daytime. And one person who does psychotherapy told me that he found it very useful to have his clients do EEG alpha biofeedback to increase alpha for about 20 minutes before the therapy session. I don't know whether that would hold up or not. I could imagine it might be useful for some, and for others it's just a waste of time, or they can't wait to get into the office to start doing serious psychotherapy. I don't know, but in the future, alpha itself is perhaps not the only one that we would want to really look at. It's really the relationship of many other things. And let me say too, with regard to the EEG, it too certainly needs more explorations, but there is a technology known as magnetic resonance imaging which can provide so much more rich information because it gets more closely to the metabolic processes that are involved in brain. And I can't wait for the day when you can buy a whole MRI device for a couple $1,000 and have people come to your place. That will happen sometime, perhaps, but it hasn't yet. I think that, meanwhile, though, why not each of us decide to learn something about many of us are clinicians who have some biofeedback equipment. Serve as a subject yourself and then try to see if you can kind of really get a clearer picture of what it is that you're doing when you're learning to do that, and be able to differentiate that from other feelings. Maybe we become better trainers if we ourselves undertake the specific measures that we are giving, because then we can have a perhaps clearer, a better chance of understanding some of the strange words that people use to understand their to describe their states. Yes?
I think it's very important to specify that alpha can be very bad, you know. If you have a lot of alpha in the frontal brain, you know, we have a subtype of ADHD, the alpha subtype, and if you have a lot of alpha in the frontal brain, you know, people usually have a lot of anxiety, you know. It's very, very important, you know, and even too much alpha can be, in the occipital, can be quite bad.
Oh, I see. So want to watch it and don't get yourself over alpha'd. I don't know if there is a danger in that. I suppose it could be. I do recall years ago when certain schizophrenic subjects were shown to have extremely high alpha activity. Whether that was an index of their pathology or not, I don't know. certainly one can mine the usefulness of any particular wave by just working with it and use your own judgment to decide if you need to work further with it. I think the problem with the commercialization of some of these products is that people wanted to make money and said, this is the way you can find salvation, or this is how you can get high, or this is how you can become a better lover, or whatever. And all these lines will make you money, but it won't help the cause very long. And I am a little bit worried about the fact that unfortunately, right now, the pathological condition treatments are the main reason why biofeedback equipment is being sold, and not as objects of interest for people to explore their own personalities, their own consciousness. I think it would be quite exciting for some of us to actually try some of these things ourselves, and then to discuss with each other what we are learning with these biofeedback tasks insofar as what our mental activity is concerned. Okay.
Yeah, okay. Any further questions? Noch weitere Fragen? Ja, ich glaube, das Letzte, was Professor Kamiya uns gesagt hat, ist wirklich auch nochmal eine wirkliche Anregung. Und ich glaube, Professor Kamiya ist wirklich auch da ein Visionär, auch immer schon gewesen. Und ich möchte Ihnen, I want to thank you, Professor Kamiya,
okay, thank you.
for your lesson and for this instructing and for this broad overview for biofeedback.
Yeah.
Thank you very much.
Okay.
Thank you very much.